Here we have to consider these three circuits, and in each circuits the battery is 12 volts, the source is of 12 volts, and the resistances are different. And in the first case resistance is 5 ohm, across it a 12 volt source is applied. Now let the current is here I. Now this I will be equal to, according to Ohm's law, that is V by R, which will be equal to 2.4 ampere, or this implies P1 we write here. P1 is the power dissipated in the 5 ohm resistor in the first case, that is equal to I square into R, or P1 will be equal to 2.4 square, I is equal to 2.4 square into 5, that is equal to 5.76 into 5, which will be equal to 28.8 watt, this much. Now we will consider the second circuit, and here P2 we will calculate, and similarly here what is I? Here let it is I2, and we take this as previous one is I1. Now I2 is equal to 12 divided by 10, because here the total resistance, because 5 ohm and 5 ohm both are in series, the total resistance will be equal to RT. Here RT is equal to 10 ohm. That you can write 5 ohm plus 5 ohm is equal to 10 ohm. That is equal to 1.2 ampere. So P2 will be equal to similarly I2 square into R1 plus I2 square into R2, and both are same. R1 is equal to R2, that is equal to 5 ohm, because the power will be dissipated in the 5 ohm resistor as well as this 5 ohm resistor. So P2 will be equal to 1.2 square into R2 is 5 into 2, because both same things are added. 1.2 square into 5 plus 1.2 square into 5, that is equal to into multiplied by 2, that is equal to 1.44 into 10, that is equal to 14.4 watt. First case we got 28.8 watt. Second case we got 14.4 watt. Now third case. In third case, this 12 volt battery is applied across this 5 ohm first 5 ohm resistor, and also in the second 5 ohm resistor. Across both the resistors same voltage is present, that is 12 volt. So what we will get, this I we will get, let it be I3, let it be I4. Now I3 will be equal to 12 by 5 ampere, whereas I4 will be equal to also 12 by 5 ampere. Hence the power dissipated in case 3, P3 we are writing, will be equal to I3 square into R plus I4 square into R. I3 square, I3 and I4 both are same, that is equal to 12 by 5, which is 2.4. 2.4 square into 5 plus 2.5 square into 5, or that is equal to I made it wrong. 2.4 square into 5, or that is equal to 2.4 square into 5 into 2, or that is equal to 5.76 into 10, or that is equal to 570.6 watt. Now comparing these three, maximum power dissipation occurs in the third case. This is the maximum, and minimum occurs in the second case. This is the minimum. And if you will analyze how you will justify the answer, if you will see in the second case, R is maximum, resistance is maximum, the net resistance RT is equal to maximum, that is equal to 10 ohm. Where in the third case, R is the minimum, because RT is equal to R1 parallel to R2, that is equal to 5 into 5 divided by 5 plus 5, which is equal to 2.5 ohm. This is the minimum. As resistance is minimum, current will be maximum in this case, and I square is the dominating factor, because P1, P is equal to I square R. Here it mostly depends on the I, because it is square term. I will be maximum for which the current is maximum, and current is maximum in case of minimum resistance. That you have to write, in case of minimum resistance current will be maximum, so power consumption will be maximum. In case of, you write, in case of minimum resistance current becomes maximum, hence power consumption is maximum, or power dissipation, here power dissipation is maximum. Power dissipation is maximum. That you have to write it.